Hello everyone. Today we are going to do a problem based on influence lines diagrams. We have to draw the ILD for the vertical reactions at A, B and C, the shear force at D, the moment at B, and finally we have to draw the ILD for the shear force and bending moment at a section 3 meter right of A. In this beam, in the point D, there is an internal hinge. About the hinge, we have to locate the segments. There are two segments, ABD and DC. Here you can see that I have given different colors to the segments. First, let us draw the ILD for the vertical reaction at A. We have to remove RA and then we have to apply unit displacement in the upward direction. In the point B, there is a vertical support, so the displacement in the point B will be 0. So the segment ABD follows this way. The hinge in the point D will come downwards. In the point C, there is a vertical support, so the displacement will be 0. So the segment DC follows this way. These two angles are same. Using that, we can find this height. For a distance of 8 meter, the height is 1, but we need the height at the distance of 3, so we have to multiply with 3. In this way, we will get 0.375. This is the ILD for the vertical reaction at A. Now let us draw the ILD for the vertical reaction in the point B. We have to remove RB and then we have to apply unit displacement. In the point A, there is a vertical support, so the displacement in the point A is 0. So the segment ABD will follow this way. The hinge in the point D will come upwards. In the point C, there is a vertical support, so the displacement will be 0. So the segment DC will follow this way. We have to find this height. For the distance of 8 meter, the height is 1. But we need to find the height at the distance of 11. So we have to multiply with 11. In this way, we will get 1.375. This is the ILD for the vertical reaction at B. Now let us draw the ILD for the vertical reaction at C. We have to remove RC and then we have to apply unit displacement at C. In the points A and B, there are vertical supports, so the displacement will be 0. In this case, the segment ABD will remain horizontal. There will be no change. That is why in the point D, the displacement ends and it is 0. So the segment CD will follow this way. This is the ILD for the vertical reaction at C. Now let us draw the ILD for the shear force at D. In the point D, we have to give relative unit displacement of unity, left side downwards and on the right side upwards. We know that in the points A and B, the displacement is 0. So there will be no displacement in the segment ABD. It will remain horizontal, no change. We know that in the point C also, the displacement will be 0. So the segment DC follows this way. This is the ILD for the shear force at D. Now let us draw the ILD for the moment at B. We have to split the segment ABD into two parts, AB and BD. You can see that for BD, I have given different color. Now there are three segments, AB, BD and DC. To draw the ILD for the moment at B, we have to give unit rotation at B. We cannot rotate AB, it will remain same because in the points A and B, the displacement is 0. Segment BD, will rotate by unity. In the point C, the displacement is 0, so the segment DC will follow this way. This height will be equal to the horizontal distance BD, which is 3. This is the ILD for the movement at B. Now we are going to draw the ILD for the shear force and bending moment at a section 3 meter right of A. Let us keep this point as E. Now we have to split the segment ABD into two parts, AE and EBD. You can see that for AE, I have given different color. First, let us draw the ILD for the shear force at E. We have to give relative displacement of unity at E, left side downwards and on the right side upwards. In the point A, the displacement is 0, so the segment EA follows this way. In the point B, the displacement is 0, so the segment EBD follows this way. And in the point C, the displacement is 0, so the segment DC follows this way. To find this height, we can use the formula A upon L. Here A is 3 and L is 8. 3 upon 8, it will be 0.375. To find this height, we can use the formula B upon L. Here B is 5 and L is 8. So 5 upon 8, it will be 0.625. These two angles are same. Using that, we can find this height. This is the ILD for the shear force at E. Now let us draw the ILD for the moment at E. We have to give unit to rotation at E. To find this height, we can use the formula AB upon L. Here A is 3 and B is 5. So 3 into 5 upon 8, it will be 1.875. These two angles are same. Using that, we can find this height. This is the ILD for the moment at E. Now we are going to end this session. Thank you for watching this video.